Okay, so over the next 2 days, so today and Monday, we're going to be talking about trigonometric functions at any angle. Now, we've kind of done this with our unit circle, and today we're going to stick with angles on the unit circle to still continue to work with. But then on Monday, we'll talk about trigonometric functions at angles that are not on the unit circle, okay? We'll talk about coordinates, we'll talk about reference angles, those sorts of things. But today we're just going to focus on all of those angles that are either on the x or y axis or 30, 45, or 60 degrees away. Okay? So let's just kind of get warmed up here. I would like you to evaluate these three using your unit circle. I will let you have your unit circle out if you would like. So go ahead and get that out. But I'm gonna give you about 2 minutes at your table to come up with the ratios for these three trig functions. It's okay to talk to each other about it too. Okay, so the cosine of 4 pi over 3. When you look at your unit circle, 4 pi over 3 is this angle right here. You look at the xy coordinate. And Nathan, what coordinate do we care about?
The x.
And what is the x coordinate there?
-1/2.
-1/2. Okay. I don't know if I brought this to your attention in first hour. Over here, I have these triangles. These are what we used the other day to make your unit circle. You notice how they look like bow ties, right? So these four angles that make a bow tie, they all have the same xy coordinate, right? These four angles that make the bow tie. Okay, so I'm gonna maybe talk about like the angles in the bow tie. This is what I'm referring to over here. Okay, and that's for you to look at if you need. Now, -210 degrees. Yes, that's on the unit circle, but we should probably think about its coterminal angle. Which quadrant is -210 in? Okay, the second would be right here, right? Coterminal with which angle? $150, right? A positive 150, okay? So if we look at a positive 150 degrees, okay? Gracie, how do we determine the tangent ratio? Okay, so we have to take sine over cosine to get negative radical 3 over 3. Right? The 2's cancel, and we have 1 over radical 3. Okay? Anytime you have one of those angles in the 30-degree bow tie, the tangent's going to be some sort of radical 3 over 3, whether it's positive or negative. And I'm hoping the more we do this, the more you're not going to have to write this down. It's okay if you write it down, but some of us are going to be able to think about this in our head. Okay? All right, 11 pi over 4. That's like more than one time around, right? So we go one time around, and then how much more?
Just before.
Right here?
Yeah.
So it's just under 3 pi. So it's the coterminal angle with 3 pi over 4. Okay? Cosecant is the reciprocal of sine. Okay? Eli, what is the sine at this angle?
Radical 2 over 2.
Okay, so we have to take the reciprocal of radical 2 over 2, which gives us what?
Radical 2.
Good. Okay, when we take the reciprocal and then rationalize, we get to radical 2. Okay? Something else. Eventually, you're just going to remember that it rationalizes to radical 2 and not have to do the work. Okay? Because we do these enough. Now, what I like about today is we're going to sort of work backwards. Okay? In today's homework, you're going to have a few of these again, but then you're going to also have something like this. The cosine of theta equals 1/2. Okay? Good morning. Okay, thank you. So I want to know any angles theta between 0 and 360 or 0 and 2 pi that would satisfy this. So essentially, I am asking you to think about one rotation of the unit circle and what angles would make sense up there. So the cosine of theta equals 1/2. How many times does the cosine equal 1/2 on your unit circle? Twice. Okay? If we think about, it's all students take calculus, right? There are 2 times where the cosine is negative, or 2 quadrants where the cosine is negative, and 2 quadrants where the cosine is positive. Okay? So let's talk about degrees first. Okay? The cosine is positive in the first quadrant. Which angle in the first quadrant is the cosine ratio 1/2? Okay. Then we have a positive cosine ratio in the fourth quadrant as well. So when we look at the fourth quadrant, which angle has a cosine, or an x, of 1/2? 5 pi over 3. Okay. An angle in that same bow tie, right? They should be similar angles. They have the same reference angle. Okay. In degrees, this would be 60 and 300. Okay. All I'm asking you to do is think about your unit circle and pick out the places where this would be true. Let's try another one. The cosecant of theta equals radical 2. Kind of nice. We sort of just talked about the number radical 2, right? You can think about this in your head, or you can write it down Radical 2 is the reciprocal of what number we've been talking about? Radical 2 over 2. So if it helps, you can say, okay, this is the same thing as the sine of theta equaling radical 2 over 2. That would be the reciprocal. If it's easier for you to think about the reciprocal function, that's fine. Okay? So now we need to think about the two angles on our unit circle where the sine is a positive radical 2 over 2. Okay? Jack, give me one.
45 degrees.
45 degrees would be 1, which is the same thing as pi over 4. Okay? In the first quadrant, the sign is positive. Brecken, give me another one. 135 degrees. The sign is also positive in the second quadrant. Okay, so at that 45 degree bow tie, we're talking about a sine ratio of radical 2 over 2. All right, I'm going to give you another problem up here, and I want you and your podmates to come up with the answer or answers. The tangent of theta equals undefined. Where does that happen? Caden, which two angles did your table come up with?
90 degrees and 270 degrees.
Okay, at those two angles, we have either 0, 1 or 0, -1. To where when we take y divided by x, we would be dividing by 0. Okay, good. So in radians, pi over 2, and 3 pi over 2. I'm going to ask you to give me both degrees and radians for your answers on these problems. Okay. All right, two more. The sine of theta equals 0. I want to know where on your unit circle is the y coordinate 0. Kelly, where did that happen? Okay, I'm going to come back to, and I'm going to point something out, and I'm going to be pretty flexible with this. You are exactly right. Your instructions are going to look like this right here. Do you notice how there's a less than or equal to with the 0, but there's not equality with the 360? So in this case, like if you were to check your answer in the back of the book, they would say 0 and 180, and they would not put down 360. But if you put down 360, I'm not going to throw a big fit about it. Okay? Because 0 and 360 are coterminal angles. I'm pretty flexible. But I want you to understand like the book's instructions and what you're going to see like when you check your answers. Okay? So 0 and pi would be those radian measures. Probably what you're going to have to get used to the most, we've already seen a reciprocal function, but then our tangents and cotangents, we're going to have to kind of get used to what those ratios are. Now, at your 45 degree bow tie, tangent and cotangent is going to be 1 or -1. And I'm hoping that that is something that you've noticed, especially with our activity yesterday. But as you do these problems, keep that in mind. If the tangent is 1, we're looking at the 45-degree bow tie, not any of the quadrangle angles. But here's one that might take a little thought process for us. The cotangent of theta equals radical 3. The cotangent is one that you can really think about a lot of different ways. You can think about it as 1 over tangent. You can think about it as x over y. I'm pretty flexible what you do with it. Let's talk first about which quadrants our angles are going to come from. So since the cotangent ratio is positive, what are our 2 quadrants? First and third. If we talk about all students take calculus, the tangent ratio is positive in the first and the third, therefore the cotangent ratio is going to be positive in those also. Okay? Now, we know that the cotangent ratio is x over y, and this is the thought process that I would take. If you don't automatically know which bow tie this is in, because some of you know, and that's wonderful, but if you're not quite sure which bow tie this is in, you at least know it has to be 30 or 60, right? Because there's a radical 3. So what I would do, I would think about this. Am I going to get radical 3 by taking 1/2 divided by radical 3 over 2, or radical 3 over 2 divided by 1/2? Which one is going to give us the ratio of radical 3? The second one. When we cross out those 2's, we're left with radical 3 over 1. Okay, so this is the ratio that we want, not this. Okay, well if cotangent is x over y, we need to figure out the coordinate where x is radical 3 over 2 and y is 1/2. Which angle is that? I think it's 30, right? Okay. And so then in the third quadrant would be, so we have pi over 6 and 7 pi over 6. Okay, I'm going to pause our video, I guess stop our video, and I'm going to teach you a trick real quick.